OK，上个星期的 exercise 有问题吗？有问题就跟我讲，在那个 chat，type it in the chat. Let me know which one you want to discuss. If you don't have, then I will pick a few questions to simply like spend 15 minutes look at it. Then we'll continue with the next lesson. Yeah, today I'm going to teach the next part of the lesson. Yeah, also I heard 你们的 exam 好像是全部 cancel 是吗？好像是这。I'm not sure about that. I think all of your exams cancel. OK，
是咩？
我不是很清楚。我看到那个报纸，我没有认真去看完啊。我是他讲什么，or any types of be cancelled something like that 啦。Maybe you can check with your teacher, your school teacher or what. Okay, because 因为现在都差不多5月了，你们的 exam suppose 如果跟着平时 schedule 是5月的那时候，然后你们5月有一个放假的嘛，是不是 ？So think
是啊
now also entering May, so I don't know what will happen next 啦。所以就 exam 没有了就可以黑一下这样啦，没有什么东西做这样。Yeah, good news and bad news also 啦。Okay, so okay now let's go into it. Let's go into it now. Okay, no question. I see in the chat no question here. So I just pick a few lah. Pick a few, talk about it, then we proceed. Okay. There's something I want to highlight here. Okay, question 2. Diagram 10 shows two identical plasticine sphere and P and Q drop from the same height. So drop from the same. Now these two plasticine spheres have the same mass, 一样重量 and 一样高度。我let go 它们是 meaning that they will be moving at the same speed, right? Same speed, u, and when they hit, they will also be stopped. Okay, v equals to 0. Now, P falls on a sponge while Q drops on an iron block. Which of the following is the same for both P and Q on impact? Now, A is, it says that impulsive force. Now, we know that impulsive force, F equals to the rate of change of momentum, mv minus mu. So mv minus mu is the change of momentum, and divided by time, meaning that it is how fast the momentum is changing. We call it rate of change of momentum. Okay, so is the impulsive force the same? No. Why? Because you see this impulsive force 在那个 formula 里面是 it is dependent upon the time of impact, right? It's how fast the momentum change. Because this one, these two sphere, they hit different material. The sponge will have a longer time of impact. So because of the flexibility, like it's very elastic, right? The sponge is more elastic, right? So the sphere tends to sit longer at the surface compared to the iron block. The iron block is very hard, right? So the time of impact is different, and thus the impulsive force is different. Okay, now let's skip for B first. Look at C. C, the time of impact, yes, also out. D, deceleration. Deceleration also not the same, right? So the harder surface, iron block, will give a faster deceleration, greater deceleration. So the answer left is just B. B, impulse. Now, impulse, again, I want to highlight impulse and impulsive force. impulse is almost the same with impulsive force 它是 Ft equals to mv minus mu. So 这个 Ft 是 I， 也就是 impulse equals to mv minus mu. Now impulse is only the change in momentum. It's not the rate of change. There's two difference here. Change of momentum 跟 rate of change 不一样啊。Now impulse here is saying that the change of momentum is the same for both of them. Yes, this is true. Why? Because they have the same mass, 一样重量，一样 initial velocity, and 一样 final velocity. So the momentum change is the same. The only difference is that how fast is the momentum change. Okay, how fast is the momentum change, and that is impulsive force. Right? So the answer is B. The answer is B. It's the same impulse. Okay, next. Number 3. Okay, number 3, you have a graph here, force versus time graph. Now, what is the total impulse experienced by the tennis ball due to this impact? So this graph shows the motion of the force diagram, or the motion of tennis ball when it hits a ball, when it hits a wall, right? Let me draw it here. So this is the wall, and we have tennis ball hitting the wall. Now, notice that from 0 to 0.1 second happen very fast, right? 0.0 to 0.1. The force increases from 0 to 20. Now, the point here is that 那个 force 不是 constant force 来的。Okay, 这个要注意，就是这个 force 在改变 ，it is changing over time. Okay, it is not a constant force. It is changing over time, and since it is changing, we cannot just straight away put in the formula for impulse. Again, your impulse is I equals to Ft, right? Meaning that this force and this time is changing. Okay, it's changing. So I cannot just take 20 force and I put inside the formula 20 and then times, what is the time? 0.1 here, 0.1. No, cannot, right? So because the force is changing, then we have to consider the whole diagram. The whole diagram means this force diagram. How do we calculate the impulse? We have to take the area under the curve, which is the area here. Okay, see my shaded region, all the area under the curve. So every time when you encounter this type of question, remember that force, this one is changing over time. So I have to take the area under the curve, right? So area under the curve is area of the triangle. Okay, should be no problem calculating area of triangle. So 0.2乘高除2, so you get 2, right? So the answer is 2 Newton second. This is the impulse. Okay, next one. Let's look at what else you have. Okay, number 7. Just number 7 is not that complicated. It's just that I want to emphasize something. Okay, number 7. Now, a ball of mass 5 kg strikes a wall with a velocity of 5 meters per second. Now it bounces back with a velocity of 3. So you have initial and final. So if the ball is in contact with the wall for time 0.10 second, what is the average force? So all data are given. So it asks you to calculate the force acting on the wall, meaning that it is an impulsive force. Okay, so F equals to mv minus mu divided by time. So time 你有了 wait okay, 你有了 time, 你有了 mass, your velocity, so should be no problem. So how do we calculate? 5 kg. Now, one thing you have to be careful again. So the force initially it is moving towards the wall. After the collision, after the impact, the ball is moving away from the wall, right? So the final velocity should be negative because it is acting opposite to the initial velocity. So initial velocity u is moving to the right and it is positive, right? So we always use positive for motion to the right, easier to remember. Okay, so 右边加左边减. Now 5, so mv, so you have to put a negative here. Minus 3 minus 5, u is 5 divided by 0.10 second. Okay, so this one you will get negative 400 Newton. So if I ask you to label the impulsive force in the diagram, sometimes they ask you to label one. Okay, so how do you label? You label here. You see this one, your answer is negative 400, right? So your arrow should be pointing to the left. Okay, from the wall, point to left like this. My purple arrow. Okay, let me draw again. Look, chat. Okay, like this. Yeah, my red arrow here. Okay, should be pointing, and then you label this one F equals to. Now when you label, 当你 label 这个 diagram 的时候是，你不要去写减400，因为你已经是画了那个 arrow 是，你就不用再写减，你直接写400 Newton， right？ 只是在 equation 里面你要写减嘛，因为在 equation 里面你没有办法画那个arrow 出来给他看嘛， so the negative sign 代替那个 arrow direction。 But when you draw the diagram, remember this, huh? When you draw the diagram, then you don't need to put the negative value. Okay, so 只是写 F 等于400 N. Okay, so the answer is 400. Okay, we do two more. Okay, two more. And what else? Really no question. 真是没有问题啊。Okay, never mind. We do two more, then we move on, right? Question 17. Sometimes the unit can be very confusing sometimes. 17. So impulse is a vector quantity. It has unit Newton second. Which of the following unit also belongs to impulse? Okay. So formula. So whenever you encounter this unit type of question, right? As long as you remember the formula, then should be no problem for you. Okay. So I impulse equals to Ft. Yes, 也可以是 mv 减 mu. Okay, so the unit F 的 unit 是 Newton, T time 的 unit 是 S. So this is your first unit for impulse. NS, Newton second. Now 这个就是 momentum 咯，是不是这个 this is mass 嘛 ？Mass is kg. So what is the unit for velocity? Is speed, right? Velocity is the same unit as speed. So you have ms minus 1. Okay, so this one should have the same unit. 这个也是 kg, 这个也是 ms minus 1. Okay, now 你看，因为这里是一个减字，这里是一个减，所以如果你拿 kg ms 减1，你减另外一个 unit 是它也是一样，也是 we are still dealing with kg ms minus 1. OK， 就很像你拿4 cm 减3 cm， 你拿到1 cm， 你的 unit 也是一样是 cm 来的嘛，没有变哦这边。OK， 可是如果我拿4cm，我拿4cm 乘3cm，连这个就是12，哎呀，12cm square。So this one your unit change，这个 cm does not equals to these two, is not the same because this one is multiplication and this is minus. Okay, so remember that plus and minus, they don't change the unit. For addition and subtraction, they don't change the unit. So this is very important when you want to derive the unit. Okay, of course, this question 17, it asks you the basic one. Sometimes the question can ask you very complicated one. 它给你很多那种 symbol， 然后它讲 find the final unit. Then you have to slowly convert this one to this one. Okay, the point is this one negative, so your unit is the same, kg ms minus 1. Okay, hopefully it doesn't confuse you. Right. If you still don't understand, then just let me know. Okay, just let me know. Okay, now so I, you have two units, ns and kg ms gen e. So your answer is kg ms gen e. Okay, last question is I want to say discuss question 20. Question 20. Okay. A bullet of mass 10 gram moving at 100 meter per second strikes a log. It undergoes uniform deceleration and stops in 8 centimeter. The impulse on the log is how many? Okay, let's draw simple kids diagram. This is the log lah. All right. Now the bullet moving 100 meter per second. The mass is 10 gram. So it carries a momentum, right? The bullet carrying a momentum. Now it strikes the log and then finally it stops. So finally its momentum when I say it finally stopped, meaning that the momentum will eventually reduce down to 0. Okay, so the initial momentum is, let's calculate the initial momentum, mv. So yeah, mu lah, same lah, mu. So this one is 1, 2, 3, so 0.001 kg times 100. So the momentum is 1 kg ms minus 1. This is the initial momentum, and after it strikes the log, it eventually stops, meaning that the momentum will become 0. So there is a change in momentum here, meaning that the change of momentum is 1. Okay, change of momentum is 1. So the question asks the impulse on the log is, so we know that impulse is also equal to the change of momentum, right? So back to the principle of conservation of momentum. The momentum of this bullet will be transferred to the log, all of it. Okay, momentum is conserved. Remember this one? Momentum is conserved in the system, meaning that the momentum lost by the bullet equals to the momentum gained by the log. Okay, so I write down here momentum loss 等于 momentum gain, lost by the bullet gained by the log. So meaning that the impulse for the log is same, 1 kg ms minus 1. Okay, it's the same. So this one also 1 ns. A, the answer is A, 20 is A. Okay, now let's continue with the lecture again. Okay, it's not going to be a very long lecture. So like 40, I take 40 minutes to explain to you, then you off to your exercise. I don't want to take too long, otherwise you will fall asleep. Right, because it's almost this evening, very 很眼睡的时间. Right, now okay, let's spend 40 minutes here. Just pay attention here, and then the rest I will give you the exercise. Then you can go to rest something. Okay. Now, force. Today we talk about forces in equilibrium. Maybe you have learned about this, or maybe you have not. Doesn't matter. Just look here. Okay. Now, forces in equilibrium. Now we know that so far 我们知道 we have learned that forces are in equilibrium. Let me write this down. Forces are equilibrium when the resultant force acting on the object is 0. Okay, so when the resultant force acting on any object is 0, we say that the object is in equilibrium, we say that. Or you can say the forces are in equilibrium, meaning that balance, right? So the scenario can be as simple as a box resting on the surface. Okay, so this one, if I ask you to label all the forces acting on this object, so you label this one, weight, cannot escape from weight. Since you have a surface, so you have reaction pointing out of the surface, perpendicular to the surface, right? And then maybe you have pulling force over here, and you have also pulling force over here. Okay, so all this has to be in the same magnitude so that there is no net force. Second can be as simple as like a moving ball at constant velocity. I write CV, constant velocity. So constant velocity meaning that what are the forces acting on it? It can be, again, weight, again, reaction, okay, reaction, and you have a force here pushing it, and maybe frictional force at the surface here, F, frictional. Okay, so in this case, the frictional force is also same with the force applied, same in size, same in magnitude, right? Which is why it can move in constant velocity. So in this system, we also say that there are no resultant force. Okay, the third one, it can be strings. This one you will learn about this one, pulley system and strings in the later chapter, right? So you have a box hanging here. What are the forces? Label all the forces. So simple system, you label all the forces, cannot escape from weight. Now, is there any surface? Is the object touching any surface? No, right? No, right? It's not on the ground, it's not on anything. It is hanging. So if there's no surface, then there's no R. There's no reaction force, all right? So the surface is replaced by this one, the string. Okay, so we got string, meaning that we got tension. Okay, so string is tension. So the tension, how you label tension is always point the arrow going outward from the object. Not to the object, going out from the object. That's how you label the tension. Okay, now this one also balance system. Now we have maybe the last one, airplane. I like to do airplane because I study airplane in university. Okay, right now airplane. This one, you have weight, lift. There's no reaction, right? The airplane is not on any surface, right? It's flying, right? So it's in air. So in air, then what is the upward force? It's not tension because no strings is attaching to the airplane. Otherwise, except you are playing the 玩具 airplane, right? So this one, So lift, you have lift from the wings. And then thrust is from the engine. And drag is the air resistance. Okay, so if the airplane is moving at constant velocity, then the thrust and the drag is the same. Okay, then they move at constant velocity. So all these are the balance system. So from all here, we know that resultant force, we can summarize in a few words. Resultant force is actually the combined, we say in more specific, vector combination of two or more forces. Okay, resultant force is nothing but the vector combination of two or more forces. 什么意思是 vector combination？ vector 就是有方向。OK， 有方向的我们加它，可是是有方向的加。OK， 什么意思 ？For example, now let's say you have this point. Let's do a point, so I don't have to draw so many objects. Okay, so this one, let's do a point, and then you have 5N force acting to the right and 3N force acting to the left. Now again, this may look simple to you, okay, again, but I still need to repeat just to make sure it is wired in your brain, all right? Now, 3N to the left and 5N to the right. Now, the way I write resultant force, we calculate FR, resultant, okay? Stands for resultant force, equals to, now the vector combination, meaning that it is the vector sum. We can say vector sum. Okay, so in AdMath you have one chapter which is the vector. I don't know if you learned about it or not, because I'm not sure your 从真的 syllabus is 怎样, but 我知道建国还没有学啊, but supposed to be in Form 5.1, 应该是在 Form 5的 chapter 来的这个 vector, right? So I think if it's in Form 5, right, they should put it in Form 4.1, because in Form 4 physics, you start to deal with physics, right? Physics, you've got many vector addition. So I think that chapter should be in your Form 4, right? So never mind now. Effect vector sum. So F resultant equals to, now, always remember, to the right is positive, to the left is negative. Now, since force is a vector quantity, okay, so when you plus these two forces together, the 5N you need to put back positive 5N. Okay, 当然加我们不用写出来，我只是写出来给你们看罢了。Okay, so 加 5N, and then you have to plus because we are taking the vector sum, right? 加 and then this one is negative 3N. Okay, simply because 3N is acting to the left. Now this one, and then you get 5 minus 3 and 2N. Okay, so this one you have to label to the right. Resultant force is acting 2N to the right. So if you want to sketch it out like this, FR equals to 2N. Okay, so this one, another one, let's say you have, instead of horizontal, you also have vertical. So 5N here, 5N here, and upward 3N, downward 5N. Now, this one you have two directions. So you need to work out the resultant force for the horizontal and the vertical. Okay, so let's take the horizontal direction first. So we write Fx. 因为它在 x-axis 嘛 horizontal. Okay, so the way I write Fx. Fx equals to, you have 5N and 5N. So one is positive 5N, and then plus minus 5N. Okay, you can straight away write minus lah, it's the same. Okay, so you get 0N. So there's no net force in the horizontal direction, and find the vertical direction, Fy equals to, now same, if for vertical 去上面就是加，去下面就是减，所以你有加 3N 减 5N. So this one you get negative 2N. Okay, so negative 2N, then you label it is acting downwards. It is acting downwards. So if you want to draw the force, then from here, you point the arrow downwards, but you write 2N. not negative 2n, not negative 2n, because you already write the arrow. Okay, so the arrow already account for the sign. Okay, 箭头已经代表那个 sign. So write down. So this one, the point object, if it is acted by all these forces, meaning that eventually it will move downward. Okay, it will move downward because your horizontal only downward here. Okay, now this one. Okay, let's look at another one. Okay, this one should be no problem. Okay, just to get familiar with it. Right now, let's say you have a car here. You have four cars. The first one, F1 and F2 and F3. And here we have F1, then F2, F3. This one we have F2, F3, and F1. Last one we have F1, F2, and F3. Now, if I ask you, all forces have the same magnitude. Find the one that has the maximum resultant force. Okay, so since all forces having the same magnitude, then you can just cancel out the forces that is acting on the opposite direction. Okay, so look at the number one first, this one. Number one, so this one you have F1 acting to the left, so it will cancel out this one, either F2 or F3. Let's cancel out this one, these two. Okay, because one left, one right, since they are having the same magnitude, so left F3 acting to the right. This is the resultant. So case 2, on the right hand side, you have F2 and F3 opposite direction. So you can just cancel out these two. Okay, so they will even out each other. So left F1 acting to the left. In the third case, you have all the forces acting at the same direction. So this one is all of them. Right? Now the final case is F1 will be cancelled out by F3. Okay, or you can just cancel these two. Right? Cancel F2 and F3. So left F1. So the resultant, greatest resultant is obvious, this one, number 3. Okay, so they are all acting to the left hand side. Okay, this one is actually a SPM question. All right, okay, now next one. Oh yeah, 我现在剩下1分钟，我 quit now，我再invite你们 right? So I don't have to redraw everything.